A series is absolutely convergent if the absolute value of the series is convergent. So what the absolute value does for us is it basically neutralizes this -1 to the n plus 1 term, because now there's no more signs. Now it's just straight addition. And if you look at n equals 1 to infinity of n over n plus 2, this is actually something similar in the textbook that we see right at the beginning of the divergence test. The divergence test says, think about the limit as the sequence goes to infinity in its terms. And if the limit as n goes to infinity is anything other than 0, in this case the limit's 1, that means it diverges. So this diverges by the divergence test. Okay, and if you're not sure why the limit as n goes to infinity is 1, think about the n behavior of the model. Think about what happens as n gets incredibly large. This plus 2 doesn't matter anymore, right? A billion over a billion plus 2 is getting really, really close to 1. Okay, so the n behavior of the model is dictated by, when it's a rational function like this, is dictated by the highest powers. So it's an n to the power of 1. And so the ratio of those coefficients is 1 over 1. So you might remember from previous studies, that's a horizontal asymptote. Either way, the limit as n goes to infinity of the sequence is going to be 1. So since that's not 0, the divergence test tells us that diverges. The limit as n goes to infinity needs to be 0 for there to be a chance of convergence. So it does not converge absolutely. We just found out the absolute value diverges. So to see if it converges conditionally, you want to apply the alternating series test. So here's the two conditions of the alternating series test. Look, we failed condition 1. The limit as n goes to infinity for the sequence, for this portion, needs to be 0. And we just evaluated that when we were applying the divergence test. The limit is 1, so it also fails the alternating series test. It does not converge by the alternating series test. So not at all is the answer here, because it doesn't converge absolutely. The alternating series test says that it doesn't converge conditionally. So this series diverges. It does not converge at all. Okay. If the limit as n goes to infinity of b sub n is 0 for a different series, then the next thing you need to check is to make sure that it's decreasing, that the next term is less than the current term. And if both of those conditions hold, then you can say it converges conditionally.